In this video, I'm going to demonstrate how to use jMetrik to run a Rasch analysis. jMetrik is a free and open source psychometric software package, and it runs on Windows and Mac and Linux. This is the website. I'll make sure to leave the link in the description box under the video. Please check it out. In order to install jMetrik, if you are using Windows, just scroll down please to this section, download jMetrik's version 4.1.1. That's the latest one that I'm using. I personally downloaded Windows installer with JRE. If you don't have JRE, that's Java Runtime Environment, I recommend that you download this. This is going to take more time than Windows installer on its own. If you're using other machines, you can use Mac and Linux installers. In addition, what I would like to show you here is the book which has been specifically written for jMetrik. It's called Applied Measurement with Metric. I'll also leave this link in the description box. Now that you have installed the software, you can see the icon on your desktop. You can click to open it. I've already done that, so I've opened it. In order to run a Rasch analysis on this software, you need to have a data set first. The data set I'm using is here. It includes 10 items and also a gender variable on the left hand side. The 10 items are right here. 5 of them, I mean from here to this column, column F, measure grammatical ability, and 5 of them measure vocabulary skills or vocabulary ability. So it's basically a test of lexicogrammatical skills or abilities. I'm going to read this to jMetrik. The first thing we need to do is to create a new database from this menu, from the Manage menu. Click on New Database, and this will appear. You can name your database as anything you like. I'm going to call it Test3 because I have quite a few other databases called Test1, Test2. So create. You wait for this. Okay. Now that the database has been created, you can open the database. The one that I have already created is Test3. These are previous databases that I created. Open. Next, again, go back to Manage and associate the data file that you have with that database. There are two types of files that you can read through jMetrik. One of them is CSV and the other one is .txt. The most recent edition, that's the one that I'm using, also allows you to import data from SPSS. But for this demonstration, I'm going to use this CSV file. So import data, and you can call this data anything. For example, for my test, I'm going to call it grammar and lexical, gramlex for short, and browse in order to find that file on my desktop. So here is my desktop, and I can find my data file there, CSV. Click OK and import. Okay, so import is now completed because I didn't receive any error message. That means that it's been successful. And as you see from this word right at the bottom, the corner, which reads ready, so you have some assurance that the data has been transported. Now you can see this little icon popped up. This means that your data set that you created is recognized by jMetrik. So click on it and you'll see all the data you have. Gender, the test items, which are 10. So that seems good. At the bottom here you can toggle to variables. In this window, we need to command jMetrik to recognize the type of the test items. We still have not done that. In order to do that, we need to go to Transform and Advanced Item Scoring. There are two ways of doing this: Basic Item Scoring and Advanced Item Scoring, but I prefer Advanced Item Scoring because interestingly it's easier to use and more powerful. So I'm going to click this and this window pops up. Now for all of my items I only have two options, 0 and 1. So 0, the score is 0. For 1, the score will be 1. And that's it, 0, 0, 1, 1. Next, let's transfer all the items to this panel. I click this arrow, and all of those items, including gender, are transferred to this side. But gender is not an item. I'm going to move it back to the previous panel. Next, we click Submit. And make sure to validate this code here. How do we validate it? Make sure that we see options 0 and 1, which we entered previously, and the scores 0 and 1. And then click OK. Before I go ahead, I should say that if you have other options, such as, let's say you're using a multiple choice question, you have got A, you've got multiple choice B, you've got C in your data, and you've got D, etc. It's easy. You can just provide the scores, for example, score 1, score 0, and score 1. That means that B is the key, and since 0 and 0. Now if this is how you score any of the items, you need to move that item to this side. For example, item 2 and item 1 are scored in this way. Then you click Submit, and then the jMetrik will understand that this is the key for only these two items, and you can enter other keys for the rest of the items if you will. So I'm going to reset this actually, because there are some codes that do not apply here. Again, I have to go through the same process, 0, 0, 1, 1. Okay, the codes are fine. Now I'm going to move all the items back except gender and click Submit. I validate it. The scoring syntax is fine. Then I click OK. Now nothing has happened so far because we need to refresh the data view first. After refreshing it, you can see the scoring 0, 1 in brackets followed by 0, 1 in brackets for all the items. And items are recognized as binary items. That's what we have, so this is good news. Next, we can go back to our main menu, the data, and also start the analysis. Under the Analyze menu, we can get frequencies, descriptives, correlations, item analysis, differential item functioning, Rasch measurement, and IRT. I'll cover IRT in a separate video. For the time being, I would like to quickly show you how to, for example, get descriptive statistics for each of the items. You can do the same for frequencies and correlations. Feel free to do so. Okay, so I'm going to move everything to this side except gender, and everything, all of these statistics are quite interesting, so I'm going to leave the default options as is and click Run to get the results. And there we are. So we are provided with a number of statistics like the number of cases and the number of valid cases. My data is about, it includes 1,200 test takers data. The minimum of item 2, that's grammar 2R, is 0, that's correct, and the maximum score is 1. The mean score is 0.8975, which is pretty high, which indicates that this item is pretty easy for these test takers, with a standard deviation of 0.034, and skewness and kurtosis may not make a lot of sense because this is binary data. So I'm not surprised to see that the skewness is slightly below -2, and kurtosis is pretty large, which might indicate some deviations from normal distribution, but it should be fine. So for the rest of the information, you can just go through the rest of the items as you scroll down. There is the same information repeated for other items. Under Analyze menu, now I would like to choose Rasch analysis. So Rasch models, I'll move all of these items to the panel on the right hand side. I'd also like to get a PCA of standardized residuals. This is the principal component analysis of residuals, which is also available in Winsteps. This is a dimensionality check for us. So I'm going to choose this. For items, I'm not going to choose anything else. If you're interested to save person estimates, you can click this. If you're further interested to see how fit your persons were, you can also save them. Again, if you're interested to get residuals, you can also get them, but I'm not interested to do so. So these statistics should be fine. The maximum of iteration is 150. You can leave it as is, and the conversion criteria should be also fine with the maximum extreme score adjustment of 0.3. I would suggest that you leave this as a default and click run. Let's do this. Okay, the analysis is done. Great. So the first thing that has been provided is the difficulty of the test items, which, well, this is the easiest item. Item number 2 with a difficulty of minus 2.65 logits, and the most difficult one to me, it seems like this item. But this is a maximum difficulty, meaning that this item was probably not answered by any person or not by many person. I mean, we can check later the distribution of the people who answered it correctly. Next is the standard error of measurement for each of these difficulty statistics. As I have talked about this in previous videos, a standard error can be interpreted as a kind of interval, plus and minus interval, within which the actual difficulty parameter would fall. For example, this difficulty parameter for item 2 would fall between minus 2.65 plus and minus 0.10, which is fine. I mean, the standard error is not very high here, it's pretty small here, but the standard error of this item, which is extremely difficult, is pretty high. So we're not very confident about the difficulty value or difficulty parameter for this item. For the rest of the parameters, you can see that the standard errors of measurement values are small. Next, we have two fit statistics, weighted mean square value and unweighted mean square values. I've talked about this before, but I would like to cover them again. Weighted mean square, otherwise known as infit mean square value, is an inlier sensitive statistic which is weighted by its statistical information or model variance. So those values that fall between 0.8 and 1.2 for multiple choice questions indicate that the measurement was fine. In this case, we see that all the weighted mean square values fall between the same range that I mentioned, and as a result we have one piece of information that the items were functioning pretty fine, and there is a standard deviation for the weighted mean square as well. Next is the unweighted mean square value. The unweighted mean square value is analogous to outfits, and this is an outlier sensitive statistic, and the same range of 0.8 to 1.2 applies here as well. As you see, all of these statistics fall between 0.8 and 1.2. What I did before starting this video was I quickly compared the results of this analysis with the results of Winsteps, as you see in this chart, and I found that they're exactly the same, except that some of the statistics have been rounded up in Winsteps, but they have not. They have been rounded out in jMetrik, sorry, but they have not been rounded up in Winsteps. For example, for the difficulty value of the items in this column for jMetrik, item number 2 has got a logit difficulty of minus 2.65, and the same thing can be observed for Winsteps. The last item is GV5, that's QV5, sorry, and its difficulty value is 0.15. The same value has been replicated by Winsteps. So if you go through the rest of the statistics, you'll see that you can get more or less the same statistic that has been generated. So this provides some evidence that jMetrik and Winsteps can reliably give you the same sort of fit and difficulty values. Next is the score table, in which you convert a score to a theta or to a difficulty value or ability value. For example, if your score is 0, then your theta, or the estimated or the measured ability, will be minus 4.1925. On the other hand, if your score is a 9, your estimated ability will be 3.9024, etc. Next is the scale quality statistics, which is very useful. On the left-hand side here, you have statistics for items, and on the right-hand side, you have statistics for persons. And actually, we can compare the reliability statistics first with those that have been estimated by Winsteps. This file on the right-hand side is outputted by Winsteps. So for reliability of items, it's almost 1 in jMetrik. That's 0.9966. And for Winsteps, you can see it's more or less the same, reliability of 1. Like I said, in Winsteps, things are rounded up and down. In jMetrik, it seems that they haven't, which is pretty fine. The number of separation levels, or the separation index, is 17.1337, and we see it's more or less the same in Winsteps. It's 17.12. For persons, the a reliability statistic in jMetrik is 0.3554, which is 0.35 in Winsteps. And finally, the separation index is 0.7426, which is 0.74 in Winsteps. So you see that the statistics are more or less the same in both of these analyses. Now, the last thing that we need to look at is to make sure that the data was unidimensional. As you remember, we requested a principal component analysis of residual in jMetrik, and these are the results. What we should look at first is the magnitude of the eigenvalues in the contrasts. So the first eigenvalue is 1.28. The second eigenvalue is 1.23, etc. As you see, this eigenvalue is much smaller than 2, and of course also smaller than 3. Therefore, there is no evidence that the data we were looking at is multidimensional. We can run the same sort of analysis. This is Winsteps. I have covered this in quite a few videos previously. Please watch those videos if you're interested to see how Winsteps works. I right-click on the interface and I get a dimensionality check quickly. I can compare the eigenvalues of the contrast in Winsteps versus those that have been outputted by jMetrik. 1.28 is the eigenvalue for the first contrast, as I said, and 1.2780 is the eigenvalue in the first contrast for that was generated in Winsteps. In the same way, you can see a very good correspondence between the eigenvalues of the second contrast in Winsteps, 1.2133, 1.233 in jMetrics. The third one is 1.19, 1.1914, sure, more or less the same, etc. But the point is that both of them indicate that the data is normally distributed. The last output that we want to look at is the statistics for persons. So I'm going to toggle back to the variable view. And as you see in the variable view, we have quite a number of new rows which were not there before. And this indicates that new variables have been added to our data. Examinee sum score, examinee score, etc. Now let's find these. We need to toggle back to data and this is our original data, and this is the data that has been outputted here. So we have quite a few columns here. One of them is the theta, theta for every person, then the standard error of theta being the ability estimated by Rasch measurement. And we've got weighted mean square values, which, as I mentioned before, is the in-fit statistics, and the standard deviation of it, together with the unweighted mean square value, or the outfit value for each person, and the standard deviation of the outfit value. So this helps us quite a lot, because you can move this to a statistical software like SPSS or even Excel and see what you want to get out of it. For example, to correlate these statistics with other measures that you have obtained from another Rasch analysis of a separate test. Okay, so that's all about Rasch measurement in jMetrik. I hope you've enjoyed this video. I'll catch you next time. Have a great day.